Welcome to the video that we're going to be talking about the different types of attacks that you vulnerabilities that you might come across as you're testing for vulnerabilities. Some of the ones that we're talking about are ones that would be in scope, and some of them that we talk about here would be ones that are usually out of scope. So make sure again you're checking that and following any policies, but we're just discussing them so you know what these types of vulnerabilities are and kind of how they work. So the very first one that we're going to talk about here is remote code execution. So remote code execution is pretty much what it sounds like, is that once a hacker remotely accesses the system or the target, or as you might often hear, the victim, the hacker would remotely execute code. And when I say hacker in this situation, it would be you, but you're not going to actually, most likely, you might to demonstrate the vulnerability, but actually execute the code. You're just looking for, again, you're looking for where it's possible. You're not then going to really go out and do the pen testing side of it, where pen testing is actually exploiting vulnerabilities that are found. So there's that key difference. You might have to do a little bit to actually make sure there's that vulnerability there, but keeping it very limited and making sure it's staying on the finding the vulnerabilities instead of finding and then exploiting them. But again, so with this type of vulnerability, what makes it more serious is the idea that this hacker could be anywhere in the world. They do not have to be at the site or at wherever the system is, the server, website is located. It could be, again, anywhere in the world and can be remotely executing code on another system. So this is also a very serious type of attack, as it can progress to lead to a complete takeover of the system. So then another term that you might often hear with this type of attack is that it can also be known as remote code evaluation. And one of the more famous ones that you can read about and might have heard of already is the WannaCry, and that's they made use of which WannaCry is a ransomware attack, and it made use of remote code execution to actually execute and as part of its attacks. Another one that you might encounter, and all really just depends on what type of database they use, whether it is SQL, but is the SQL injection attack, or SQLI, as you might hear for sure. And so this is where, so you go to a website and there's a form field, or a text field within a form, and whether it's a password form or username form or just some other form that's somehow linked to a database, it's where you could input an SQL string or SQL query and override whatever it's doing. And so oftentimes, like an SQL injection, if it's vulnerable to this, it could allow modifying of the database or the data, reading of the data, or deleting a whole database or a whole table. More often than not, if you're going to be deleting something, it would most likely probably be only a table. But if they really wanted to go after it, they could just delete the whole database. And that's why this one can be so serious, is because, again, if you delete a whole table or a whole database, that's not good and causes very important or very critical damage. And if you delete, again, the whole table, an example of this would be if you were deleting a user table. Let's say there's a login form and a hacker successfully executes a SQL injection attack, and what they injected was a SQL query that said drop table users, as you can kind of see here in this example. So what that would do is it, as I kind of say, it deletes the table. It gets rid of it. And so now that hacker has now successfully executed not only an SQL injection attack, but also a denial of service attack. And you might be wondering, well, you could probably maybe figure it out, but the reason it's a denial of service attack as well is because now there's no users table. So now anytime someone tries to log in, it has no username or logins or any login information to check it against. So now no one can access that system. So that's why it's very important to protect against this type of vulnerability. And so as you can see here, so from a website that might have SQL, you would probably see something like select star. So star, in case you really don't know SQL, syntax means, okay, select everything from the whole row that it finds from the users table, where user ID, so again, this would be like on a login form, they would type in the user ID. So what they're doing, that looks like a double quotes, but it's actually a single quote, and then close it. So they would, so it's actually a double quote and then plus user ID. So, well, it's again that single quote where it's open, close, and then saying plus add the user ID to that. Then the user would then input 100. So that's, again, that user ID. Then the semicolon, which in SQL ends the query, and then drop table users, semicolon. So that's finishing that first query, saying, okay, look up the user ID 100, end that query, start the new query, drop table users, and then end it. And then that's what they would put into the form. They would hit enter, and now the final one, once that data goes to the backend, would look like this. Select star from users, where user ID equals, that should say 100, and then semicolon, okay, so now they're ending that, it ends that query, it's done that, it's on the record, it's done everything, and then goes to the second query, drop table users. So then it would go and delete the users table, which now again successfully executes that SQL injection attack, which would then ultimately become a denial of service attack. So the next one we're going to be talking about is DNS spoofing or ARP poisoning. Well, and ARP poisoning. So DNS spoofing attack is, for those of you that don't know, DNS stands for domain name system, which is when you type in www.google.com, computers don't know that, don't know what google.com is. So it goes out to a domain names system server, says, hey, where is google.com? It returns that IP address, and then it goes to that IP address. And that's where but then also once it gets there, your computer will create what's called a DNS cache. And the DNS cache is, okay, it's already gotten the IP address for that site. So now, anytime in the future, or for usually a period of time, depending on the computer, would be like, okay, we already have that IP address. We don't need to go back out to that server and get that IP address. It just gets to that IP address, the one that has in your DNS cache. So a DNS spoofing attack would be where someone edits your DNS cache and they could point it to any IP address of their choosing. So now, if you try to go to google.com, it could go to, in a realistic situation, would go to a website of the hacker's choice and try to maybe steal some type of data. But it won't look completely different. The hackers are going to try to make it look very similar to the website that you're trying to actually go to. But ARP poisoning is, and so with the DNS poisoning, that's kind of what you're seeing here is, so you have your user client that makes the request to the genuine website, and then it goes out, and then before it actually gets that, again, the hacker would have injected the fraudulent website or fraudulent DNS entry. So then when the user makes that request, it goes there and be like, okay, go to this IP address. And then goes, instead of going out to the real website, it goes up and up to the malicious website. So now again, with the ARP poisoning attack, that deals with MAC addresses. So in your computer points to a gateway or to some other device, let's say a router, and which is how it's accessing the internet. And that router has a MAC address that's listed somewhere on your computer in some setting. So in ARP poisoning is where they would go in and change that MAC address to point to some other place. So now when it points to there, it's sending its traffic to there, which then allows the hacker to do other things as well. So that's another thing to look out for. The next one that we're going to be talking about is the click jacking, which is where a hacker imposes something on another object of a legitimate website. So as you can kind of see in this picture, you have the actual button that says pay, but then the hacker, as you can see, is placing the play button over that pay button. So to the user, it says play, and like, oh, well, it's playing something. So most likely would be on like a video website or somewhere that it would seem logical to have a play button. So then the user clicks that, but ultimately they're not clicking that play button. They're clicking what's beneath that, which is the pay button, which could then automatically maybe send a payment of some amount to that hacker. And so ultimately, the attacker is hijacking the clicks of the users and having them click what they want them to click instead of what they're actually thinking they're clicking. So this can be very hard to detect because obviously if it's put over top, you don't know there's something underneath, and so that's why it can be very difficult to detect for that. So that's one you kind of it's hard to protect, but you just kind of try to keep an eye on. So the next one is the denial of service attack, which I've kind of already briefly mentioned in the past, but that is where you bring down a complete system and prevent authorized users from accessing it. So with this type of attack, as pictured, there's a sample kind of DNS attack or denial of service attack. And actually what's kind of pictured here is not only denial of service attack, but what's called a DDoS. It's a distributed denial of service attack. And the reason it's called distributed is, as you can see here, so you have the hacker machine that then would have what's called botnet or ba, which then, when you have multiple of them, forms the botnet. As you can see in the second row, that would be the whole botnet. That hacker then sends commands to each of those bots and says, well, which is down there actually in the third row is the list or the group of compromised computers, sends commands to them through the servers that they have and says attack this website. So then those computers all send in packets or requests, most likely for a website, to that targeted server, which then when you're flooding them could bring that service down, which is what their hope is. Finally, we're going to be talking about privilege escalation / authorization bypassless escalation, which is all kind of the same thing. And so there's two different types of privilege escalation. And the first one is vertical privilege escalation, and that's where you're going from a user from a lower level to a user of a higher level. So commonly within a scenario, you would most likely see a hacker try to go from, let's say, user JDO, who's an employee, and have them go up to root, which is where they're going from that lower level user to that higher level user. But ultimately, there's another type out there that's called horizontal privilege escalation, and that would be going from, let's say, JDO to B Smith. So it's someone of the same or similar privileges. And you might think, well, why would a hacker do that? Because maybe they can't get to root from JDO, so then they try to go horizontally to another account that might be able to get up to the root account. So that's another attack that you might see. And one thing I'll also mention is the social engineering, where that's pretty much going out and trying to get information from users, tricking them. That's like going to be your phishing emails, spear phishing, which is against, again, a targeted group of individuals or usually a company. And then there's whaling, which is going after the top of top executives. And so that will conclude this video where we were discussing those different types of attacks and what you might see. So again, it's very important that you kind of understand how these work and keeping track of which ones are in scope and which ones are out of scope. So typically, our denial of service one would be an out of scope one, and most likely click checking probably would be too. So just again, keeping an eye and up. More likely than not, social engineering would also most likely be out of scope. So making sure you very carefully follow those and keep track of those. and making sure, again, make sure to watch any other videos that are videos that we have posted here, as it's meant, these videos are really meant to prep you and help you throughout your participation.